Okay, now we're going to look at functional groups in organic chemistry. So first of all, let's answer what a functional group is. And a functional group is a unique reactive combination of atoms that differentiates molecules of organic compounds of one class from another. And the arrangement of organic compounds into a relatively small number of classes simplifies their study. So what you're going to see when we're looking at functional groups is you're going to have a cluster of atoms together arranged in such a way that it gives some kind of predictable reactivity to a molecule. So the groups that are formed because they provide distinct patterns of reactivity. This is what I just said. And for instance, like an alcohol like methanol is going to behave the same way as a lot of other larger alcohols like ethanol or isopropanol or butanol, so on and so forth. So again, if you're still unclear after watching this slide, if you're just, I'm still not sure what a functional group is. The idea is this, is that when a chemist sees a functional group, and you have to practice, looking at them. When a chemist sees a functional group, that chemist is going to be able to say, okay, I've got an alcohol in here, and alcohols can react in a certain way. Another functional group would be something like an aldehyde. Oh, I've got an aldehyde in this molecule. Well, I can predict that the molecule is going to react in such a way. So let's take a little deeper dive into the hydrocarbons. If you remember, I told you earlier on, a hydrocarbon is some kind of molecule that has a formula of CXHY, where X and Y are just numbers. So we saw earlier on benzene was C6H6, but it's some kind of molecule that's made of only carbon and hydrogen. We call that a hydrocarbon. So there's several classes of hydrocarbons, and the first one is an alkane. And an alkane only has single bonds. Okay, only single bonds in an alkane. So if you see a hydrocarbon and there's only single bonds in that hydrocarbon, that is an alkane. And we call an alkane a saturated hydrocarbon. Why? Because it only has single bonds. So it says here it's another name for an alkane, but I want to remind you again, and I'm repeating what's on the slide already, but only single bonds. If you see a double bond or a ring, it is not a saturated hydrocarbon. So an unsaturated hydrocarbon, says here, is a hydrocarbon that contains one or more carbon-carbon multiple bonds. So you can see here an alkene has a double bond, an alkyne has a triple bond, and an aromatic like benzene has three double bonds in it. And so those are considered to be unsaturated compounds. So just so you know, carbon can have a single bond between two carbon atoms. You can have a double bond between two carbon atoms. You can have a triple bond, but that's it. Okay, there's no quadruple bond or anything like that. Okay, so if you have all single bonds, it's saturated. But if you've got double or triple bonds, that's going to be considered an unsaturated hydrocarbon. All right, so let's take a look at the functional groups. And I'm going to go through these relatively quickly in this video, but you're going to have to study them on your own time to master them. So the first one was an alkane, which technically isn't a functional group. You can see here, alkane, no functional group. That's when we only have single bonds, okay? Once you have a double bond in your molecule, if you have a carbon-carbon double bond, a double bond between two carbons is called an alkene. And when we have a triple bond between two carbons, that's what we call an alkyne, okay? Now, you might take a look at this next molecule and say, hey, double bonds, it's an alkene. Well, not exactly, because if you have double, single, double, single, double, single, alternating like this in a ring, we call that an aromatic compound. So you have to be on the lookout for those. An alcohol, just like ethanol, that's found in alcoholic beverages, if you have an oxygen and a hydrogen attached to each other like this, and the oxygen is attached to a carbon, we call that an alcohol. If you replace the oxygen of an alcohol with a sulfur, that's what we call a thiol. Thiols are very stinky compounds. All right, and you can see they've given you some examples here, and they've also drawn the skeletal structure of these functional groups. Okay, next page. When you have a carbon, then an oxygen, then another carbon, this is called an ether. If you have a nitrogen, that has hydrogens attached to it like this. It's called an amine. There's actually a few classes of amines. You can have primary, secondary, or tertiary amines. But anyhow, we'll just start with that, an amine. Next, if you have a carbon with a double bond to oxygen, a hydrogen on one side and a carbon on the other, Or technically it could be a hydrogen here too. We'll put here, I'll put here C or H. That's what we call an aldehyde. Formaldehyde is actually the simplest possible aldehyde. Formaldehyde would be this guy here, and I'm sure you've all heard of formaldehyde. Next one is a ketone. If you've ever used nail polish remover, acetone, that's a ketone. So a ketone is when we have a carbon with a double bond to oxygen and then two single bonds to carbon coming off of it like this. Next one is a carboxylic acid. It's when we have a carbon with a double bond to oxygen, then a single bond to oxygen, and on that oxygen you have a hydrogen, carboxylic acid. An ester. Ester is where we have a carbon with a double bond to oxygen, a single bond to oxygen. Then instead of a hydrogen, like in a carboxylic acid, you have another carbon. So that's an ester. And the last one is one that's very common in peptides and proteins. This is an amide. So we have a carbon with a double bond to oxygen, then a nitrogen attached to that like this, and that is an amide. And okay, again, they draw on the bond line structures of these compounds or the skeletal structures here on the far right. So again, you want to practice trying to identify functional groups. Okay, example 8.3. Identify by name the functional groups in aspartame, an artificial sweetener in foods and beverages. Please do not consider alkane a functional group for this exercise. So let's see if we can find some functional groups in here. Well, I noticed this one here, when you have a carbon with a double bond to oxygen, and then attached to that you have an OH group. This is what we call a carboxylic acid. So carboxylic acid. Then here we have a carbon attached to a nitrogen with hydrogens on it. This would be an amine. This is actually what we call a primary amine, but I'll just leave it at amine for now. Next one here, you've got a carbon with a double bond to oxygen, and then attached to this carbon here, you have a nitrogen, which makes this an amide. So I'll scribble that in here, amide. What else? We've got an ester here. You've got a carbon with a double bond to oxygen, then a single bond to oxygen, then this is a CH3 group out here, so this would be an ester. There's one more, isn't there, right? It's this big aromatic ring here. So that would be an aromatic. Aromatic. There you go. So those are all the functional groups in aspartame.